Hi, welcome to your lesson on the quadratic formula. Brace yourselves, it is almost upon us now. Let's begin here. So we've been looking at quadratic equations. Here's one in standard form. Here it is written in standard form where we have the general parameters a, b, and c. All right, we're going to solve each of these by completing the square to see what happens. So first step of completing the square, what is it? Okay, we're going to set y equal to 0. We'll do that over here also. Okay, over here we're going to move the 8 over like that, minus 8. Now we have this. And our next goal is to create a perfect square. Over here we have to move the c over as well. So the c value has been moved over to the left side. Okay, over here I think factoring out the 4 might be a great idea because that makes finding a perfect square much easier. So there's that. And over here we have to factor out the a. This might be a little trickier. Okay, we can factor out the a by dividing this by a and also dividing this by a. And when you divide this by a, we're left with b over a. Okay, on this side now we can add the number that makes this a perfect square. We're going to complete the square. We complete this square by adding 9. Remember, b over 2 squared. So there's 9. Over here we added 36 because there's a 4 here. So 4 times 9, we've actually added 36 here. So that's what we do here. Over here, things get a little trickier for sure. How do you divide this by 2 and square it? What does it look like? Alright, this is getting trickier for sure. If you're struggling with a little bit of this algebra, don't worry too much. This is definitely tough, but we divide this by 2. So if this is divided by 2, we end up with having b over 2a. And then you square that. So b squared and 2a on the bottom squared becomes 4a squared. A little bit trickier for sure. So we have that, and we add it on the other side. But again, when we have the multiplier here, we have to add this thing multiplied by that. So here we're going to add this multiplied by a. And when you multiply this by a, one of these a's cancel and we're left with just a instead of a squared. Okay, so next step here is we have a perfect square. So now that these combine, and over here this perfect square factors like this. Over here that became like this. Okay, it's like taking the square root of this, and there we have it there. All right, next step here, to solve, we divide by 4, and then we can take the square root over here to get plus or minus 7, move the 3 over. Okay, we have 2 solutions. Over here it gets even more complex. So you can give it a try, pause the video, give it a try, and then check, compare your work. So if you went further, you have this. What did I do? Oh yeah, I put the a there, and then let's see, took the square root of that whole side, okay, and we have plus or minus that, and then continuing on like that, like that, like that. This is really tricky, so I kind of flew through it, but you can take a look closer if you want. We have, in the end, this thing here, which combines to become this. This is the quadratic formula. Probably something you've seen before, but you need to know that it comes from completing a square. Basically, when we begin with a standard form quadratic, and then we solve it by completing the square, and we get the answers for x, it's always going to be in this form. This is called the quadratic formula. It is a shortcut we can now use to solve quadratics so that we don't have to go through the process of completing the square. We can just go right to this formula to get our answers. Okay, let's take some notes for sure. So when a quadratic cannot be factored, we can solve it by completing the square. We saw that in our last lesson. So when we have a quadratic like this in standard form, and when we solve it by completing the square, the result is this, the quadratic formula. This completing the square shortcut is known as the quadratic formula. So this is kind of a summary of that journey we've taken. Often when we try to solve a quadratic, we try to factor. If it can't be factored, we can do completing the square. And now we found out that completing the square actually leads to this shortcut, this formula. Okay, so let's look at this problem 3 ways, because it's nice to know that we can factor, complete the square, or use the formula, and they should all give us the same answer. So how about you solve this one by factoring first and check what your 2 answers are. So that one factored is like this, set each factor equal to 0, and we get 2 answers. The 2 answers are 7 and negative 3. Now try the same process completing the square. And you should know it's the same quadratic. You should get to the same answers, but just practice. See if you can do completing the square on this and see if you get the same answers. And now let's check as well. So there's the whole completing the square process. Then take the square root, and then all that, we have 2 plus or minus the root of 25, which is really plus or minus 5. And that does work out to 7 and negative 3. Okay, now try this formula. We've just learned this quadratic formula. We've learned that it is actually a shortcut to doing completing the square, but try it. Put the numbers in here, your A, B, C values, see if you can use this formula and again produce the same two answers. Okay, hopefully you gave that a try and you notice that in the end, putting all those numbers in, you're left with 4 plus or minus root of 10. So 4 plus 10 and also 4 minus 10 divided by 2. So you get the same two answers. So it's good to see again the journey we've taken in solving quadratics. Okay, you can also do this on your calculator. Okay, unfortunately my calculator doesn't have the proper app, but I'll show you how to do it. You're going to press the purple button here, apps. Once you're in apps, you should see a list of apps. Mine doesn't have it, but I think it's number 9 on your list, and it says PLYSMLT number 2, Polynomial Simulator number 2. Click on that. Once you're in there, you're going to have two options. Number one is simultaneous, number one is poly root finder, and number 2 is simultaneous equation solver, I think. So you're going to choose number 1, poly root finder. Then it will allow you to enter your function, and in this case our function was this, so you'll enter I think a 1, a -4, and a -21. Then you'll press graph to solve, and it'll give you solutions. And double check, your solutions should match the solutions we had here. So let me show them again. We should have 7 and -3. So when you solve that, make sure you can get 7 and -3 on your calculator. Okay, great. So let's look at another one. This one you don't have to write down if you don't want, but we can solve it by factoring for sure. So actually do give it a try. Try to solve this one by factoring. What two answers do you get? Okay. Hey, guess what? This one doesn't factor. So maybe you tried, you're like, I just can't find those numbers that work. So this is a classic situation. When we can't factor, then we're left with having to complete the square or use quadratic formula, which are the same thing, right? So let's try completing the square. Okay, so checking your work now. That 2 was factored there. Here's quadratic formula as well. I think I'm going to have them appear at the same time. Okay, so let's check. So whether you chose completing the square or quadratic formula, you get to the same answers. So check your work carefully. So completing the square had that 2 there. Solved, there's a decimal value, which is okay, plus or minus, and in the end, -7 plus or minus that. So we have 2 decimal answers, and that's usually what we'll see. When something cannot be factored, it kind of basically tells us we're going to end up with decimal answers, right? So there's our 2 decimal answers. Quadratic formula, if you put the numbers in there as well, would produce the same 2 decimal answers. Okay, so here's some key conclusions then. So the solutions of a quadratic equation like this in standard form are also known as the roots of the equation. So remember that word, when we're looking for the solutions, we can call them roots. These values are also called zeros. They're called roots and zeros because we set y equal to 0. And roots because in the end, in the quadratic formula, we can take a root of a portion of it to get the answer. So they're called the roots or zeros, and P and Q, if P and Q are the real zeros of this, then the points P and Q0 are x-intercepts. So when we find solutions, in other words, we know those solutions are x-intercepts of the graph. And that's something we've looked at. So for example, we have this quadratic. We can factor it and get 2 answers right here, -2, -3. Quadratic formula on the same one produces the same 2 answers. Okay, so that's fine. Main thing here at this point is that when you graph it, those will be our 2 x-intercepts right here, -3, -2. Those are called our x-intercepts, they're called our roots, they're called our zeros. All those words mean the same thing. They are solutions for a quadratic. Okay, so we have a quadratic, we can complete the square, we get this formula. So let's try it. Try A. Use the quadratic formula. So now don't worry about factoring, don't worry about completing the square. Let's focus only on the formula. Try to use the quadratic formula to solve this one. What solutions do you get? Okay, check your work here. Maybe you put it into decimal form, which is great, but anyway, it's 3 plus or minus root of 5. And graphing that, notice we have 2 solutions right here, and those solutions, if you did 3 plus root of 5 and 3 minus root of 5, you would get those 2 numbers here. So again, the solutions are our x-intercepts. Okay, try B. Check your work for B. Using quadratic formula, we get these 2 answers. Again, graphing that, there's the 2 solutions. If this was simplified into decimal form, it would be exactly those 2 answers right there. They are our x-intercepts. Try C. Okay, in C we have to shift things around a little bit to get 0 here. Great. Using quadratic formula, 2 answers here. If we graph that, again, there's our answers. Negative 1/2 is right here, negative 0.5, and 5/3 is 1.67. So our two solutions are our x-intercepts. Finally, try D. Okay, in D, quadratic formula gets us to this point. And maybe you got to there and you said, I'm not sure what to do. Square root of a negative number. It does not work. We've been told you cannot take a square root of a negative. So in this kind of situation, we say there are no real solutions. Notice we use the word real. We didn't say there are no solutions, because actually this is solvable, and I'll show you something about that in just a moment. But there's no real solutions. And notice if we have the graph of that, I graphed it here, notice the parabola does not intercept the x-axis. So there are no x-intercepts, and that's why we see no real solutions here. I know you're a curious person. You're wondering, what does this mean? If there's no real solutions, does that mean there's some unreal solutions? Well, let's take a look. So there's a way to solve this. This is beyond our course, let me tell you. So don't worry about this as a topic you must master, but at least I'm sure you're curious. So let's take a look together. First of all, when you want to solve that, you can actually go like this. So we know the square root of 4 is 2. So I took the 2 out and I just left a negative 1 in there. Now, square root of negative 1, there is a definition for that in mathematics. A square root of negative 1 is what is called I. It's called an imaginary number. So notice there's no real solutions, but we do have imaginary solutions now. So that root of negative 1 became I. And now we have a 2 here, so we can divide 4 and 2 both by that 2. So this simplifies into 2 plus or minus I. Okay, so there are our solutions for this quadratic. There actually are solutions, and they are called complex solutions because they have an imaginary component. So 2 plus I and 2 minus I. Let's take a look at what that looks like on a graph. So here is the red graph. That is our original parabola graphed. The blue axis and the red axis are our normal x-axis and y-axis. So when that's graphed there, notice the graph is floating above the x-axis, and that shows us there are no real solutions. It does not intersect the x-axis. However, now look at this in 3 dimensions. A third axis, this green one, has been added. This green axis is called the imaginary axis. So values along that axis represent I. Okay, now notice when we take our parabola, and from the same vertex, we take our parabola and we reflect it, and we also spin it. So now it's spun like 90 degrees so that it's facing this way instead of this way. And that parabola, which we've reflected from our original one, hits this plane, the green axis, at 2 points. And notice those points are, look at this, we have 2 here, so you go 2 on this axis, 2, and then over here, over 1 on the plus 1 on the I-axis and negative 1 on the I-axis. So here we have 2 plus 1i and 2 minus 1i. And that's what this is showing here, the distance from the axis there along the imaginary axis. So something interesting, something good to see. Don't worry about knowing the details here, just something I thought I'd share with you. Great work. There's one more video that follows this one. A natural next step after looking at quadratic formula is something called the discriminant. So there's one more video on that. Please watch that now.